Okay, well, it's Phil and Hugh again talking about Mains Part 2. And this is partially as a result of a little trip Phil's done abroad, which he'll tell you about, and some feedback from a favourite electrician of his who said there's one or two things we should mention. So, Phil, I think probably kicking over to you, what was the feedback?
Hello again. I've got your webpage up again, Hugh, just so everybody knows who you are.
Oh, right, okay, yes, of course.
And I'm just flipping it over to my webpage as well, and I'll put some lower thirds onto that. But yes, no, as you say, I had a call from a friendly electrician, Jamie Fordham, who I've worked with in the past on television-type machinery and builds, and he pointed out to me, very important thing that we didn't mention at all last time, was the fact that we're now up to revision 1, amendment 1 of the 17th edition of the IET wiring regulations. So I suppose this little podcast should be regarded, it's not going to be a very long one like our last few have been, but it should be regarded as a bit of an amendment, a bit of a postscript to the previous mains one we did. Jamie called up and said, you omitted to mention the fact that it's now the first revision of the 17th edition, and he tells me that what came in with the first revision of the 17th edition is largely to do with harmonics on main supplies. So perhaps a bit out of the scope of a 101 type podcast, quite kind of complicated business of induced harmonics on mains supplies. But again, I think I was really a little bit remiss. I didn't mention some of the other things that the 17th edition brought over and above the 16th edition.
Just before you do, for anybody that's not been familiar with the various editions, how often do the revisions come out, and how often should one check for that?
Well, we popped up a screen grab of revision 1, which was from the 1860s. So in 150 years we've had 17 revisions, major revisions, and then sub revisions between. So the 16th edition came out when I'd not long been at the BBC in 1990. And so the 16th edition saw us all the way through the 90s and the noughties, and it was revised a few times in the interim. And I think we talked a little bit about how at some point the 16th edition started to permit mixed phases within machine rooms, for example. But we're very much with the 17th edition now, and as mentioned, we're now up to the first revision, which is the green covered book. I've just popped that up, which is the sort of 17.0, if you will, if software people. So BS 7671:2008 was a red book, and now Amendment 1 2011 is a green fronted book. So if you're doing the right thing and buying yourself a new copy, then look for the green fronted book. The red one is still very relevant, and as I say, the changes are minor, but by the time the 18th edition comes round, when we're probably, I'll be even greyer, getting ready to retire, those changes will be significant for sure.
Yeah. Okay, fantastic. Sorry, I interrupted. So the changes that are in here were largely to do with harmonics and things like. We don't need to go into those particularly.
Not really. The stuff of a 101 podcast. I'd probably have to do a bit of reading to speak with any knowledge on the matter. But I did want to revisit RCDs, residual current detectors, or otherwise known as ELBs, earth leakage breakers, which we talked about in the last mains podcast. Which we keep referring to the last mains podcast. I'm just sticking up a browser window that shows where you can get hold of our previous podcast. There's a YouTube channel, and then there's Blip TV, which hosts the podcast, and then you can also get it as a podcast on iTunes. So I'll stick up the URLs for all of those, so you can find it whichever way you like. And in fact, I've been playing around with one of those new network attached Blu-ray players, and even watching it on that. So it's all the way to the telly in the living room. RCDs, and we talked a bit about RCDs and how they work, and the fantastic analogy of a hose pipe leaking, and if you use that analogy of mains power being like the movement of water through a pipe, so I'd encourage you to go back and look at that if this is the first time you've kind of come across our little offering. Residual current detectors are fooled by inductive loads. It's not something everybody's particularly familiar with, because we all think about loads as, electrical loads as being akin to DC current, and that's a very good way of thinking about it most of the time. But it is the case that with AC power, where the current is constantly varying 50 times a second in a sine wave, as we covered last time, strange things happen, particularly when you have what they call an inductive load. And what's an inductive load? Well, an inductive load is something where lots of magnetic fields are being generated. So think about modern television or data center type equipment, and it's lots of spinning hard disks. It's switch mode power supplies. It's the kind of things where a lot of energy is being stored in a magnetic field. In Lenz's law, which tells us about how magnetic fields behave when you try and change their state by changing the state of the electrical current that's generating the field, tells us that the field, because the field is essentially storing the energy that's been turned from electrical energy into magnetic energy, as the field starts to collapse, i.e. when you're coming down off the sine wave for a 50th of a second, that causes a reaction. The field behaves so as to oppose that change. That's Lenz's law, if you kind of want to go back to your A-level physics. Part of the function, the outcome of that is that in alternating currents with an inductive load, whereas if you were to put your voltmeter across a purely resistive load, a heater or a electric kettle or something like that, or a light bulb, you put your voltmeter across it, or probably more likely your oscilloscope across it, and you look at the waveform of the voltage as it varies, and you then say, okay, that's my voltage waveform. If I then break the circuit but splice in my measuring device so I can now look at the current that's going through the device, you'd see that the current and the voltage are varying in phase with each other. As the voltage builds, the current builds, and vice versa. In the case of an inductive load, that doesn't happen because the magnetic field is storing the energy of the system and is opposing the change that the now raising, the now declining sine wave of the mains is bringing to the situation. So there's a little anagram, civil. You might have come across that, Hugh.
No, I don't think I have.
So in a CIVIL, so in a capacitive load,
gosh, that takes me back.
The current leads the voltage, but in an inductive load, you have to go back into the middle of the word, the voltage leads the current. So were you to have those two waveforms up on your oscilloscope, showing the current going through the equipment against the voltage drop across the equipment, you'd see they were offset from each other, and the degree of the induction in the load dictates how far they're offset from each other. But all of a sudden now, for a very simple device like a residual current detector, or a miniature circuit breaker, I should say, which just uses heating effects to detect these things, an inductive load represents a problem, because there are times when the voltage and the current are totally all the time, they're out of sync with each other. And so not only does the miniature circuit breaker have to deal with the very high inrush of current when all those hard disks start spinning up, or when that switch mode power supply starts coming up, but it also has to deal with the fact that the voltage and the current are out of phase with each other. And so a C-rated breaker, which was the kind I had up on screen last week, will often fail because of that. So a 16 amp C-rated breaker, a C16, will often fail with only a few amps going through it if it's an inductive load. So consequently, the industry developed D-rated breakers. I've got a 20 amp D-rated breaker up on screen just to show the D20 marking on it, which tells us that that's a breaker that's good for inductive loads. And I specify those always for television installs, because they're not fooled by inductive loads. They're a bit more expensive, but they're just the thing when you've got lots of television type equipment with spinning hard drives, etc.
So just to my mind, when I think of an inductive load, I would have thought of things like lift motors and stuff like that. And perhaps to somebody thinking of computers as being rather more solid state, they're not, because there are in fact transformers. There's quite a lot of inductive stuff going on, even in the switch mode power supply. You've got a lot of things going on there. So yes, some of the equipment that you're going to find is more inductive than you might initially have thought.
Yes. So even if you put aside switch mode and resonant mode power supplies, which are more inductive than a linear power supply, traditional inefficient linear power supply with a full wave 4 diodes
rectifier and everything,
to rectify it, and it's everything. So switch mode and resonant mode power supplies are very inductive. But you look around the average television machine room, and there's probably several chassis full of spinning hard drives, configured either as standalone storage attached to each of the workstations, or as a storage area network. And that's definitely the case in data centers. You see lots of chassis with many hard disks in.
Good to check that.
Indeed.
Fantastic.
So that was really there were the two things that I thought we were remiss about. We didn't really talk enough about inductive loads and the need for derated circuit breakers, and the fact that now we're with the Green Book, the First Amendment to the 17th edition. So really, I suppose that's the any other business. Sort of we've covered ourselves there.
That's great, but of course. This is all very good theoretical mains knowledge. You've been travelling and you've come across some practical applications for mains safety where it turns out you don't actually need to be careful at all. Or is that right?
Well, you'd think so. So I've just come back from a trip to Nigeria, where myself and one of my colleagues, Dave Skeggs, we were commissioning and training the staff at Lagos Television to use a media asset management stroke archive system that we'd built for them. It turns out that quite a lot of broadcasters around the world are waking up to the fact there's value in their archive, and that all those videotapes from the 80s and the 90s that are sat on their shelf, they'd really quite like to retransmit them. They'd really quite like to feed them into the edits system and do things with them. But I've got popped up on screen at the moment the mains intake for the technical area where myself and my colleague Dave were installing this equipment, and it really is quite frightening, there's sort of stuff everywhere. Now, interestingly, one of the things that we discovered when we got there was we'd mislaid, or it hadn't been delivered, one of the boxes of parts that we needed. One of which was the 16 amp C-form connectors to the C19 inlet connectors for the back of our UPSs, and so I just said to the Nigerian engineers, I said, can't we just pop down the electrical wholesalers and pick them up? I'm sure they'll have them. And they said, yes, we can go to the electrical wholesalers. And I imagined, the kind of place you go to in London, when there's a big white counter shop top and a bloke in a sort of a shop coat, and he takes down your order and walks out into the warehouse at the back and brings you what you need. But the biggest electrical wholesaler in Lagos, I've just stuck up a picture of two very nice chaps who were very helpful, but just kind of didn't really have the bits we needed. And the biggest electrical wholesaler in Lagos is not much bigger than my kitchen, tiny, with lots of friendliness, but not much in the way of modern electrical parts. And I've just stuck up a picture of a twin gang main socket, which shows the twin and earth feeder going into the top of the socket, and clearly the socket was mounted before they put the feed in, so they just smashed a hole in the top of the socket to feed the cable in, and there's no plug plugged into the socket. There's just a couple of bare wires stuffed into the live and the
Those
neutral.
are actually bare wires, are they?
They're stripped off to the end. You can just about make it out on my very poor phone picture. The other thing that really tickled me, and we saw it everywhere we went in Lagos, because we had to go out wandering through the computer flea market to try and locate these connectors that we'd lost, is that pretty much every electrical pole in the city has got between some number and occasionally it's dozens of a little additional added on cables dropping down into the shops and the homes round about the pole. And while I was there, I saw a chap he climbed up the pole, and with a craft knife he was removing the insulation from one of the live pairs and winding on his own cable, dropping it down to his mate, and there you go, there's the main supply for their house. And I thought, wow. My word, people must get killed. And the truth of the matter is that even when you've got competent engineers, and I take my hat off to those chaps who are running Lagos TV, because they've got no money and they're keeping a 24/7 channel on the air, and they're doing amazing things with technology that we were throwing out 20 years ago, all standard definition analog stuff, and so clearly they're skilled engineers, but because they don't have the burden of having to comply with safety standards like the 17th edition and such, those things are very easily forgotten about, just because you're clever, it doesn't kind of make you particularly safety aware. So I kind of I blessed the fact that we have the 17th edition and just kind of carried on. I've just stuck up a photo of one of the workstations I was using, and I'd got in at about 9 o'clock in the morning and had a look at the log on the UPS to see how many power failures we'd had that day. We'd had 2 that day, and it was only 9 o'clock in the morning. So, the hotel we were staying at, it was a constant feature. You'd be kind of getting ready for bed or sitting on the loo or something, and the lights would all go out, and you just hear people shouting, and where are the keys for the generator? And every house and every business has a generator outside, and so as a consequence, you never quite lose the smell of diesel. You can always smell diesel. Yes. And so they're very used to their mains electricity going up and down. There's just one last picture from Nigeria, which I thought was very entertaining. It's the transmission server in their TX department, and you can see the lid's off. There are several drives of the wrong size that have been sort of jerry-rigged in that are hanging out, and that was the server that was on air as I was chatting to the guys. So I just, as I say, I take my hat off to them. They achieve great things with very limited resources, and I look forward to going back and getting to know them a bit more because I think I've got a few things to learn from them myself, and truth to tell, Nigeria's got a few things to learn from us. So it was a very good trip, but I'm glad to be back in Blighty in the UK.
So yes, that first edition came in handy, and it'll get exported at some point. Do you think?
You think so? Yes.
Mine the 17th, just the first will do. Oh, that's fantastic! Thanks, that's terrific, Phil.
Okay, so I think that's probably the end of our addendum, our postscript to the first mains podcast. There was just a couple of little things I wanted to remind people of. If anybody ever works on outside broadcast, it's often the case that the generator at the OB will be locked to the OB truck's SPG. Yeah. So you try and keep the mains frequency of the mains from your generator running at video rate, so as to so if there's any breakthrough problems, you don't particularly see them on pictures. And that was always the case when I used to do OBs. I don't know if it's the case now with most OBs being digital. I think I probably stopped going on OBs just as in the late 90s, just as things were starting to move over to all SDI OBs. But I don't know, you got any thoughts on that, Hugh?
No, I haven't been on an OB for a long time, so no, I don't know what the current thinking is. But it's a great moment to say anybody who's watching who would like to contribute, we'd like people to join in, actually. It's lovely talking to Phil. He's a very nice person. But more voices and more thoughts are very welcome.
Indeed, yes. Although we enjoy doing this, we don't want it to be the Phil and Hugh show. So anybody who's got a mind for it and maybe has some interesting things to share with the broadcast engineering community, then you'd be very welcome. And
then I think our next chat, Phil, will be something to do with your rucksack.
Indeed.
So I'm looking forward to that.
Yes, indeed.